Okay, we've talked about MapReduce, and that's kind of where it all started with Hadoop. And it's, the oldest technology for data processing in Hadoop, and as a result, it's also one of the most difficult to use. So congratulations for getting through that. The good news is there are easier ways to do this, and that's what Pig is all about. We're going to talk about Pig in this next section, and it's a scripting language called Pig Latin, built on top of Hadoop and MapReduce that lets you create MapReduce jobs without having to write mappers and reducers. So it makes life a lot easier and development a lot faster. Let's see how it works. Let's talk about Apache Pig. It's a very quick way to get a quick analysis of your data without going through all the trouble of writing mappers and reducers. I mean, that's really the whole point of Pig. So we looked at MapReduce in our previous section, and we saw how it works, and even though we simplify things a great deal by using streaming and Python, there's still a lot of work involved in writing all this code for your MapReduce job and actually debugging it and trying to just fit everything into the concept of mappers and reducers. It's not always obvious of how you would actually take a given business analysis problem and reframe it in the terms of mappers and reducers. So the big problem with MapReduce is just the development cycle time. It takes a long time to actually develop a MapReduce program and run it and get it to do what you want it to do. And that's where Pig comes in. So Pig sits on top of MapReduce, and it introduces a new programming language called Pig Latin. And it looks a lot like SQL, but it's different because it's actually a procedural, sort of a step-by-step language where you can set up different relations on your data using a very simple script format to actually do things that look a lot like SQL. So you can, select data, you can filter it, you can go through it line by line and transform it. So it's just a much easier and more compact way of doing MapReduce tasks that just lets you develop things a lot more quickly. And under the hood, it can translate that into MapReduce, and you don't have to worry about it. So it's just a lot easier to use. It's actually not as slow as you might think. So you might think that there might be a performance benefit to still sticking with MapReduce coding, but that's really not the case anymore because, like we'll talk about in a bit, Pig can actually run on top of Tez in addition to MapReduce, which is actually faster, much faster than MapReduce. So you're really not giving anything up by using Pig. Another good thing is that even if you do feel limited by Pig Latin, it is highly extensible. So it has these things called user-defined functions, or UDFs for short, that let you do pretty much whatever you want. You can have your own custom functions that plug into Pig Latin, that is. And you can even run explicit MapReduce mappers and reducers if you really, really want to. So you can have sort of this hybrid between Pig and MapReduce if that's what you really want to do. So where does Pig sit in the grand scheme of things? Well, like I said, it's on top of MapReduce and Tez. So, we have HDFS sitting at the bottom, kind of the substrate of our file system on our cluster. And then we have Yarn, the resource negotiator for Hadoop that figures out where things run and how, and that runs our resource manager and our node managers. And on top of that, we have MapReduce. So as we saw, we can code directly to MapReduce if we really want to, but it's kind of a hassle. I mean, there's a lot to be said for rapid iteration and ease of development. It makes it a lot easier to sort of experiment and poke into your data in new and creative ways. So that's where Pig comes in. It sits on top of MapReduce and offers Pig Latin as a very simple way of writing scripts to actually analyze your data that then get translated into MapReduce mappers and reducers, which then runs on top of Yarn and accesses your data on HDFS. And what's really cool is that it can also run on top of Tez. And we'll talk about Tez in more detail later in the course, but it's basically a much more efficient way of organizing these jobs. So it runs what's called a directed acyclic graph. So as with MapReduce, you have sort of this fixed chain of events that happen. You have a mapper and a reducer that feeds into another mapper and reducer that feeds into another mapper and reducer in sort of this linear manner. Tez can actually look at the interdependencies between the things you're trying to do and compute the optimal path for getting it done. So by going through Tez, you can often find that things run, in my experience, up to about 10 times faster than they would on top of MapReduce. So that's what's really cool about Pig. You can also run Pig in standalone mode that just runs by its own, doing its own thing without any of these dependencies, so you don't even need a Hadoop cluster at all for small tasks, but it can also translate its jobs into MapReduce, and it can translate its jobs into Tez, which is even faster. So again, very powerful stuff here. It's all the same Pig Latin scripts to you at the end, but under the hood it's doing some very, very sophisticated stuff to actually execute your tasks across the cluster as efficiently as possible. There's a few ways of running pig scripts. So one is sort of a command line REPL interpreter, grunt. So if you just type in pig from your master node, you will get this grunt prompt that lets you type in pig scripts one line at a time and execute them one line at a time. So if you have a small data set that you just want to experiment with quickly, that's a good way of messing around with pig. You can also just give pig a script file name, so you can save a pig script to a file and run that from the command line using pig, which also means you can run it from a cron tab or whatever you want on a periodic basis in production. And what we're going to do in our examples is actually run it through Ambari. So there's an Ambari view for pig that lets you very nicely write and run and save and load pig scripts right from the web browser, which is kind of a neat thing. So we're going to mess with that next. Now, I could blather on and on about how pig works and all the syntax of pig Latin and all sorts of conceptual stuff, but honestly, it's going to make a lot more sense if we just dive right into an example and see how it works. So to get started, what we're going to do is actually write a pig script that goes through the Movie Lens dataset and finds the oldest 5-star movies that it can find. So it wants to find really good old movies. And if you're a cinema buff and you want to go back in time and actually enjoy some movies that were based more on story and plot and less on special effects, this might be a good way to discover some things to add to your queue of things to watch. So let's dive into that in our next lecture.